Hello. As of recording this, it is May 4th, and I know that the AP exam for Calculus AB and BC are coming up in about 1 week. So I thought it would be a good idea to review some integration methods to alleviate some concerns for the AP exam. Today we'll be talking about the rule of substitution. And so what the rule of substitution is let's say we have the integral of f of u of x. So it's like a composite function, dx, or sorry, no, multiplied by u prime of x, dx, right? And so if we have a function of this form, we can say it is equal to the integral of f of u, and then we put it in terms of du now instead of dx. And so that's the main idea of the rule of substitution. Some people call it u-substitution, but really it's just called the ROS, the rule of substitution. Okay, let's do some examples. So we have the integral of the square root of pi over 6, and then go from 0 to root pi over 6. We have sine of x squared multiplied by 2x times dx. We have to rewrite it, and so we need to find a proper u. The way to find a u is equal to something where its derivative is present in the function. Alright? And so, what does that mean? For this, it means we'll say u is equal to x squared. Why? Because x squared, what's the derivative of x squared? Is equal to 2x, and where's 2x? It is right here. So then, yeah, du is obviously going to be 2x. And a lot of people make the mistake of saying, oh yeah, so now du is equal to 2x times dx because you multiply both sides by dx. That is completely wrong. If you find someone saying that, go slap them in the face. So, yeah, du dx is not a fraction, it is a function. It is a function. Alright, let's rewrite this. So we have u of our original endpoint, which is root pi over 6, and then u of 0 is going to be 0. And then we have sine of u times du dx multiplied by dx. Okay, now by the ROS, we can say that this is going to be pi over 6, is going to be 0, and then we have sine of u times du. Notice how it looks like right here, dx cancels out, but technically that's not true because it's not, it's a function. Alright, how do we antidifferentiate this? The antiderivative of sine is equal to negative cosine. And then since this is a integral, we have pi over 6, and then we minus a negative cosine of 0. There we go. And then so negative cosine is, of pi over 6 is going to be equal to this. And then we minus cosine of 0 is going to be 1, negative 1, so minus negative 1, which is plus 1. So it's equal to 1 minus root 3 over 2. Final answer. Done. Okay, let's go through another example. Let's say we have this example. A plus bx squared 3ax plus 6x, or actually bx cubed. Yeah. Okay. Alright, so usually when you do a u-substitution, you look for something that a function is taking in. So if you look at the denominator, denominator, it is the square root of something, and that something is 3ax plus bx cubed. But we also have to look for a present antiderivative. So a good thing to notice is that if we say u is equal to 3ax plus bx cubed, right, and we differentiate this, we have du, we differentiate this. 3a is just a constant, so it's going to be 3a, and then plus 6x cubed. And the way we differentiate this is we use the power rule, and we'll say, oh, sorry, this is not a 6, this is a b. Oh, okay. 3bx squared. So does this look like anything that we have seen in our integral? It sure looks like the numerator. And so maybe it doesn't look like it right now, but if we do this, looks like it now, right? So we're gonna rewrite this. We're gonna rewrite this as 3 times, or sorry. Oh yeah, 1/3. 1/3 times du dx divided by, and then we have the square root of u. As we know, constants can be pulled out. So by the rule of substitution, we say that it's 1/3 integral of 1 over square root of u, and then we put it in terms of u. Put it in terms of du. Now we evaluate this antiderivative. So if you want to do it like this is probably the better way to do it. But you have it to the 1/2, right? And then du. And then so the way you anti-differentiate this is 1/3 times u to the 1/2, right? And then we divide by the new power, which is divided by 1/2. Which is the same thing as multiplying by 2. So multiply by 2. Plus c. Oh, I'm so sorry. I forgot c. Ho ho. So 2/3. And then the square root of u. But what is u? We set u as equal to 3ax plus bx cubed. So it's 3ax plus bx cubed plus c. That is the final answer. There we go. And let's do one more example of the rule of substitution. Let's do a harder one. Let's see. Okay. This one is pretty hard. So we have the integral, or actually we have the antiderivative. Sine of 2x divided by 1 plus cosine squared x dx. And I want you guys to try and figure this out on your own before I do it. So this one is a little bit tricky, and you have to know your trigonometric identities. Okay, so we have to note sine 2x sine 2x is equal to 2 cosine x sine x. Alright, so we kind of need this for this problem. So we're gonna rewrite this problem as the integral of 2 cosine x sine x divided by 1 plus cosine squared x dx. So now we have to pick a u and du. So where can we find a u such that its derivative is present in the function? So if we pick the u is equal to 1 plus cosine squared x, then what is du? Du dx. You can use the chain rule for this. Yeah. But du dx is equal to 2 sine x cosine x. And why is this? The reason for this is because well, the 1 is going to go away, right? So this is just cosine x multiplied by cosine x. And so we'll use the product rule for this. So we have this one's derivative, which is sine x, and then we multiply it by itself, which is cosine x, and then we add this one's derivative, which is sine x, multiplied by itself, which is cosine x, and then so now you have 2 times sine x cosine x, which is equal to that. So that's why. You kind of have to see it though. This one's a little bit tricky. And so now we have du dx, right? So we're going to rewrite this entire problem as 1 over, and then u, because u is 1 plus cosine squared. Then we have du dx, right there, multiplied by dx. And then so we say, you have to say this, by the rule of substitution, we can say that this is equal to the integral, the antiderivative of 1 over u times du. This is the easiest integral ever. If you don't know this, I don't have to tell you. This is going to be equal to ln, the absolute value, remember, plus c. And then we put it back into terms of x. So we have, what was u again? U was, 1 plus cosine squared x. 1 plus cosine squared x. Absolute value closed. Plus c. That is the answer. So I hope you learned something while watching this, and I'll see you in the next video. Thank you.